Welcome to part 1 of our series on the Milky Way galaxy. Today we're diving into 10 fascinating facts about our cosmic home. I'm Alexander Bringadal, and it's a profound privilege to guide you on this journey. Imagine, if you will, a sprawling city of stars, dust and mystery, so vast that its light takes 100,000 years to cross from one end to the other. This is our galaxy, the Milky Way, a spiraling colossus that cradles our sun, our Earth, and indeed us. We are, in a very real sense, children of the Milky Way. Its elements forged us, its gravity holds us, and its story is inextricably linked with our own. Today, we'll peel back some of the veils that shroud this magnificent structure, venturing from our own stellar neighborhood to the monstrous black hole at its heart, and even peering into a future collision of cosmic proportions. Prepare to have your perspective shifted, your curiosity ignited. The universe is under no obligation to make sense to us, yet the more we learn about our galactic home, the deeper our connection to the cosmos becomes. So, let's embark on this exploration together, to marvel at the grandeur of the Milky Way, and to better understand our place within its swirling, starlit embrace. The journey begins now, into the heart of our very own island universe. It might seem obvious, but ponder this. We are not just observers of the Milky Way, we are inhabitants deeply embedded within its structure. Our solar system, our Earth, our very existence is nestled within one of its many spiraling arms. This particular arm is known as the Orion Arm, or sometimes the Orion Spur. It's not one of the grand primary arms of our galaxy, but rather a smaller partial arm located between two larger ones, the Sagittarius Arm and the Perseus Arm. Think of it as a quieter suburban street in a bustling cosmic metropolis. This specific location, far from the turbulent galactic center and away from the dense star-forming regions of the major arms, might be one of the reasons life could emerge and thrive here. We reside in a relatively calm stellar neighborhood, a cosmic comfort zone. Gazing up at the night sky, the band of light we call the Milky Way is, in essence, our sideways view of our own galactic disk. A humbling reminder that we are looking out from within this immense city of stars, trying to map its streets and comprehend its sheer scale from our own tiny, precious vantage point. Our Milky Way is an entity of truly staggering proportions. If you could travel at the speed of light, the ultimate speed limit in the universe, it would still take you approximately 100,000 years to cross from one edge of its luminous disk to the other. Imagine a beam of light setting off from one side when our early human ancestors were first mastering tools, only arriving at the other side in our modern era. This vast expanse contains not just stars but also colossal clouds of gas and dust, the raw materials for future generations of stars and planets. Yet for all its grandeur, our Milky Way is not the undisputed champion of galactic size in our local cosmic neighborhood. The Andromeda Galaxy, our nearest major spiral neighbor, is even larger, perhaps twice as massive and spanning an even greater diameter, estimated at around 220,000 light-years. And beyond Andromeda, out in the unfathomable depths of intergalactic space, lie galaxies that dwarf even Andromeda, like IC 1101, which stretches millions of light-years across. It's a profound lesson in cosmic humility. We live in a giant structure, yet it's just one among countless others, in an ever-expanding hierarchy of scale. Contemplate the sheer number of stars within our Milky Way. Current estimates suggest there are at least 100 billion stars, and some calculations push that figure up to a breathtaking 400 billion. Each one of those stars is a sun, a fusion furnace, many potentially with their own retinues of planets. Our own sun, the star that gives us life and warmth, is but one solitary member of this immense stellar congregation. Try to count them. If you counted one star every second without rest, it would take you over 3,000 years to reach 100 billion. This vast stellar population isn't uniformly distributed. Stars are born in clusters from collapsing nebulae. They live out their diverse lives, some burning fiercely and briefly, others shining steadily for eons. And they eventually die, sometimes in spectacular supernova explosions that enrich the galaxy with heavy elements. Each point of light in that hazy band across the night sky represents distant suns, and around them, who knows how many worlds. The possibility for countless other planetary systems, some perhaps like our own, staggers the imagination, and fuels our search for understanding our place among them. Our entire galaxy, this colossal assembly of stars, gas, dust, and dark matter is not static. It's in a constant state of rotation, a majestic cosmic carousel. The region where our solar system resides is whipping around the galactic center at an astonishing speed of approximately 828,000 kilometers per hour, or about 514,000 miles per hour. That's over 230 kilometers every single second. Despite this incredible velocity, the Milky Way is so immense that it still takes our Sun roughly 225 to 250 million years to complete just one orbit around the galactic core. This period is sometimes called a galactic year. Think about that. The last time our solar system was in its current position in the galaxy, dinosaurs roamed the Earth. This grand rotation is a delicate dance orchestrated by gravity. The combined mass of everything in the galaxy dictates the orbital speeds of its components. And it's this very rotation, when studied carefully, that gave us one of the first major clues to the existence of something unseen, something mysterious, dark matter, which we now believe makes up the vast majority of our galaxy's mass, its gravitational influence essential to holding our spinning city of stars together. At the very heart of our Milky Way, shrouded by dense clouds of gas and dust, lurks a monster. This isn't a monster from fiction, but a very real, very powerful astrophysical object. A supermassive black hole named Sagittarius A star. This colossal entity possesses a mass equivalent to about 4 million times that of our Sun, all concentrated into an incredibly small region of space. Its gravitational pull is so immense that nothing, not even light, can escape its grasp once it crosses the event horizon. For years, astronomers gathered indirect evidence of its existence by observing the frantic orbits of stars near the galactic center, whipping around an unseen, massive object. More recently, the Event Horizon Telescope collaboration even managed to capture an image of the shadow of this black hole. But fear not, Sagittarius A* is not a cosmic vacuum cleaner indiscriminately sucking in everything around it. It's relatively quiescent, and our solar system is a comfortable 26,000 light-years away, safely orbiting far from its direct influence, though its gravitational presence is fundamental to the overall dynamics of the galaxy's central regions. When we picture a spiral galaxy like our Milky Way, we often imagine a perfectly flat symmetrical disk, like a spinning celestial pancake. However, the reality is a bit more complex and frankly more interesting. Our galaxy's disk isn't perfectly flat. It's warped, bent, and twisted, particularly at its outer edges. Imagine a vinyl record left out in the sun. It starts to ripple and contort. The Milky Way exhibits a similar kind of large-scale warp, with one side of the disk bending upwards and the other downwards relative to the central plane. The reasons for this galactic contortion are thought to be gravitational. Past interactions or ongoing tugs of war with nearby satellite galaxies, such as the Large and Small Magellanic Clouds, are prime suspects. These smaller galaxies, as they orbit the Milky Way, can exert enough gravitational force to perturb its disk, pulling and twisting it out of shape over eons. It's a dynamic cosmic dance, a reminder that galaxies are not isolated islands but are constantly interacting with their environments, their shapes sculpted by the gravitational ebb and flow of the cosmos. On a clear moonless night far from the glare of city lights, you can witness one of the most awe-inspiring sights available to us on Earth, the Milky Way galaxy itself, stretching across the heavens. It appears as a faint, luminous band, a milky river of light arcing from horizon to horizon. This ethereal glow is not a cloud in our atmosphere, but the combined light of billions upon billions of distant stars, their individual glimmers merging into a collective radiance. It's our home galaxy, seen from the inside, looking out towards its dense, star-packed plane. This celestial spectacle has captivated humanity for millennia, inspiring myths, legends, and the very beginnings of astronomy. What you're seeing is the disk of our galaxy, edge on. The brightest, densest part towards the constellation Sagittarius marks the direction of the galactic center. Sadly, for a growing portion of humanity, this majestic view is lost to light pollution. Seeking out a truly dark sky to behold our galaxy in its full glory is an experience that connects us not just to the cosmos, but to generations of stargazers who looked up in wonder before us. Our Milky Way may seem like a serene and stable island universe, but it has a rather voracious appetite. It's a galactic cannibal, constantly in the process of consuming smaller, dwarf galaxies that stray too close. Over its billions of years of existence, the Milky Way has grown by merging with and absorbing numerous such smaller stellar systems. This isn't a violent, explosive process like a Hollywood movie. Rather, it's a slow gravitational dismantling, where the larger galaxy's tides rip the smaller one apart over hundreds of millions of years. Astronomers find evidence of these past feasts in the form of stellar streams, long, faint trails of stars and globular clusters that arc around and through the Milky Way's halo. These are the shredded remnants of dwarf galaxies, their stars now incorporated into our own. And the feasting isn't over. The Sagittarius dwarf spheroidal galaxy is currently being torn apart and assimilated by the Milky Way. This process of accretion is a fundamental way that large galaxies like ours are built and continue to evolve over cosmic timescales. Not only is our solar system orbiting within the Milky Way and the Milky Way itself rotating, but our entire galaxy is also hurtling through the vastness of intergalactic space at an incredible speed. Relative to the cosmic microwave background radiation, the afterglow of the Big Bang, which provides a sort of universal reference frame, the Milky Way is moving at approximately 2.1 million kilometers per hour, or about 1.3 million miles per hour. That's roughly 600 kilometers every second. Every moment we are passengers on this colossal galactic ship, voyaging through the cosmic ocean. This motion isn't random. Our galaxy is being pulled by the gravity of other, even larger structures in the universe. We are part of the local group of galaxies, which itself is moving towards the Virgo cluster. And the Virgo cluster, along with our local group and other clusters, appears to be influenced by an even more massive concentration of matter known as the Great Attractor, and perhaps even larger structures beyond that, like the Shapley supercluster. It's a cosmic flow, a grand ballet of gravitational attraction on the largest scales imaginable, all part of the universe's ongoing expansion and evolution. Peering into the distant future, our Milky Way is destined for a truly monumental event, a collision with our nearest large spiral neighbor, the Andromeda Galaxy. Andromeda is currently about 2.5 million light-years away, but it's approaching us at a speed of roughly 110 kilometers per second, or about 400,000 kilometers per hour. Barring any unforeseen cosmic detours, this galactic rendezvous is set to begin in about 4 to 4.5 billion years. This isn't a destructive crash in the way two cars might collide. Space is mostly empty. When these two majestic spiral galaxies merge, individual stars are unlikely to collide due to the immense distances between them. Instead, the galaxies will pass through each other multiple times, their gravitational forces distorting and reshaping them, flinging some stars into intergalactic space, and eventually settling into a new, much larger and likely elliptical or lenticular galaxy, a cosmic behemoth sometimes nicknamed Milkomeda or Milkdromeda. Our sun will likely still be shining, though it will be nearing the end of its main sequence life. Our distant descendants, if any exist, will witness a night sky transformed, a testament to the ever-changing dynamic nature of the cosmos. And there you have it, 10 glimpses into the majesty, the dynamism and the sheer mind-bending nature of our home galaxy, the Milky Way. From our quiet stellar neighborhood to the supermassive black hole at its core, from its warped disk to its future cosmic dance with Andromeda, our galaxy is a place of endless wonder and ongoing discovery. Each fact we uncover is like finding another piece of an infinite puzzle, revealing more about our origins and our place in this vast cosmic tapestry. Thanks for joining us on this cosmic journey. Stay tuned for part 2, where we'll explore even more incredible facts about the Milky Way galaxy. The universe is rich with stories, and our own galaxy is a library filled with them, waiting to be read. We've only just scratched the surface of what there is to know about this swirling city of stars we call home. Don't forget to like, subscribe, and hit the bell icon for more amazing content. Keep looking up, keep questioning, and never lose that sense of wonder. For it is in our curiosity, our relentless pursuit of knowledge, that we truly connect with the grandeur of the cosmos. Until next time, may your skies be clear.